if dk is this determinant where you have first row as 1, 2k and 2k minus 1, and then second and third row, they have terms containing n. If summation dk k from 1 to n, this is 96, then we have to find the value of n. Now, in case of determinant, we learned one important property that in a determinant, if any one row or any one column is sum of two elements, right? For example, let us say first row is a1 plus b1, then you have a2 plus b2, and here you have a3 plus b3. This is our first row. And the second row, this is let us say c1, c2, c3. And the third row, this is d1, d2, and d3. If I have this determinant where any one row is sum of two elements and the other two row, they have c and d. So this you can break as sum of two determinants, right? And this thing is true whether you have two elements in any one row or any one column, provided the other two rows or other two columns, they are same, right? So here you can write this as sum of two determinants. For first determinant, the first row will be a1, a2, a3. The second and third row, that will be same, right? Second row c1, c2, c3, and then d1, d2, d3. This will be one of those two determinants. And for the second determinant, you can take the second element only. That means here you can take for first determinant, the first row was a1, a2, a3. And for the second determinant, the first row will be b1, b2, b3. Then here you have c1, c2, c3. And then we have d1, d2, d3. Now, this is one important property that we are going to use in this problem. If any one row or any one column is sum of two elements, then you can split that determinant as sum of two determinants. Uh, the second and third row you will keep same, and the first row will contain these three elements a1, a2, a3. That will be the first row of this first determinant. And the first row of second determinant, this will be b1, b2, b3. Now, this property we can use in reverse manner also. That means if I have two determinants and for both of those determinants, second and third row are same, then basically we can add the corresponding elements of first row, and this we can do column wise also. Now, here if you notice, dk and k is only present in first row. So if I calculate d1, the second and third row will be same, right? They will have n square plus n plus 2 and so on, and only the first row will change, right? In d1 you'll have 1, 2, and then 2 minus 1, that is 1. In d2 in place of k will have 2 and so on. So that means here if I want to add all of those determinants, we can just add the corresponding element of first row, which means that this sigma notation we can take inside this determinant along the first row. So if I need summation dk, now we can write this thing as summation dk. This is given as 96. So this means we can take that sigma notation inside the determinant, and we can write this as sigma 1 n and n. Similarly, sigma 2k, and then we have n square plus n plus 2, and here we have n square plus n, and finally we have sigma 2k minus 1, and then you have n square plus n plus 2. So this will be sigma dk, right? And obviously k is from 1 to n, and now this sum, this is given as 96. So this is one important property, but remember that this variable k, this must be along any one row or any one column. Then only we can take this sigma notation inside, right? So we can take that sigma inside the first row, and now we have to expand this determinant. First, we have to simplify those terms. So sigma 1, this will be nothing but n. Sigma 2k, 2 we can take outside, n into n plus 1 by 2. So this is nothing but n square plus n. And sigma 2k minus 1, this is sum of first n odd natural numbers. And we know the standard formula is n square, right? Sum of first n odd natural number is n square. Similarly, here we have n square plus n plus 2, n square, n square plus n. I mean, now this is a standard problem of properties of determinant. The important concept was that sigma notation, if we have k only in one row or one column, then we can take that sigma notation inside the determinant. Now let us create two zeros using row and column operation. So here we can perform this operation that in place of R1, we can do R1 minus R2, right? That will give us 1, 0. And similarly, in place of R2, we can do R2 minus R3, right? So if we perform this operation, then in place of first row, R1 is R1 minus R2. So this will become 0. Here we'll get minus 2. This will also become 0. R2 is R2 minus R3. So again 0. Here we'll get 2. And this will be minus n plus 2. Here we'll get n. And because we have two zeros here, these two elements will not contribute to determinant. Right? If I have two zeros, if these two numbers are 0. So then these two elements, they are not going to contribute to the equation of determinant. So now this will be n. I'm expanding along the uh, first column. So n into these two minus the other two elements. So 2 into n plus 2. This is 96. From here you can see that n into n plus 2 and 96 by 2 is 48. On left hand side we have two integers and difference between those two is 2. So 48 we can write as 6 into 8. And then directly you can see because n is positive integer, n is number of terms, so n must be 6, right? By creating quality also you can solve, but I mean directly you can see that using hidden trial that n is 6. And therefore, the correct answer, this was integer type problem, so the correct answer for this problem will be 6, right? So this was again one important concept from determinant, that if these two rows are um, same in the two determinants, then basically we can add the corresponding element of first row, and which implies that, I mean, if we have more than two determinants, then also we can add the corresponding element of first row. So sigma notation we can take inside the sign of determinant, and then after that, using a standard properties of determinant, we got n at 6. So that is the correct answer for this problem.